Today's lesson, section 12.2, we'll be talking about a little bit more with arithmetic sequences, and then also talking about partial sums for arithmetic sequences. So, for this first one, it wants us to find the first 5 terms of the given sequence, and then determine if it's arithmetic. If it is, find the common difference and express it in standard form. So my first term, if I plug it into this, would be 1 plus 1 over 2, so that would be 3/2. And then second term would be 1 plus 2, so that since that's 1, that gives me 2. And then 1 plus 3/2, so that gives me 5/2. Fourth term, plug it in 4, that gives me 2 for 4 over 2, so that gives me 3. And then fifth term would be 1 plus 5/2, which would equal 7/2. Now if I want to look at these other numbers in the same format as the fractions, so it looks like we go up by a half every time, and so our difference is the same. So 3/2 to 4/2 is a half, 4/2 to 5/2 is a half, so this must be arithmetic, so I'd say yes, it's arithmetic. Okay, the first term we need to identify, it looks like it's 3/2, and our common difference is that 1/2. So now we need to be able to write a arithmetic sequence in standard form. So a sub n, where 3/2 is your a, plus n minus 1 times 1/2. Okay, now you can always check, so if you plugged in 1 minus 0 gets you 0, times 1/2 is 0, plus 3/2 is 3/2, so that gets you your first term. And then 2 minus 1 is 1, times 1/2 is 1/2, and then plus 3/2 gets you 2. So then it looks like it kind of follows what we want it to be, so that would be my answer. Okay, let's move on to example 2. Now here, you want to be able to find a different term. So if you're given the 12th term of an arithmetic sequence is 32, and the 5th term is 18, we want to find the 20th. So this one we kind of have to set up a 2 equations and use like a system of equations kind of way to solve. So the a sub 12th term, and using my standard form, so a plus n minus 1, we do know n, so it's 12 minus 1 times d, and that's supposed to equal 32. And then the 5th term will be a plus the 5 minus 1 times d, and that's supposed to equal 18. So now I need to kind of find my nth term, or my standard form for this equation, and then I can figure out what the 20th term is. So let's simplify these equations a little bit. So 12 minus 1 is 11, and 5 minus 1 is 4. So then I can write a plus 11d equals 32, and then a plus 4d equals 18. Now here you can use substitution, elimination, if you could graph if you wanted to, but you probably won't want to do that. So I noticed that the a's are the same, so I'm going to use elimination. So I'm going to stack them. And then because a's are the same sign, I subtract. So then a minus a cancels out. 11d minus 4d gets me 7d. And then 32 minus 18 is 14. So then dividing 7 to both sides gets me a value of 2 for my common difference. And now I'm going to go plug that in for one of the equations. Since this one's sitting all nice and pretty over here, I'll do it for this one. So I plugged in into the a plus 4d equals 18 equation. D is 2, so 4 times 2 is 8. And now subtract 8 to both sides to get a by itself, which gives me 10. Okay, so now I have both those values. So let's set up our equation. So 10 plus n minus 1 times 2. And so now I want to figure out what the 20th equation, or 20th term is. So my n is 20. So 20 minus 1 is 19. So 10 plus 19 times 2, which is 38, and then add 10 to that gives me 48. So that must be my 20th term in this arithmetic sequence. Okay? Now here I want to be able to talk about partial sums. Now we've already kind of discussed this, but for arithmetic sequence it's a little different. So for arithmetic sequence that has a sub n equals a plus n minus 1 times d form, the nth partial sum should be s sub n is equal to a plus d plus a plus 2d, and then always all the way up to that nth term form. And so there's two different formulas that we can use to help find a partial sum given what that, like, the nth term is. So you can either use n divided by 2 and then times 2a plus n minus 1 times d, or you can use n times a plus the the nth term kind of value and divide by 2. So the second one's kind of like a midpoint, and then you multiply it by the number of terms that are going on. The first one kind of looks more like the regular format. It's just also with the n divided by 2 in it as well. Either one works. It doesn't matter which one you use. You could use one all the time, but sometimes some of the problems give you particular information that makes one just easier because it's already ready to go for you. So it's up to you which one you would like to use. Okay, so like example 3, here they want us to find the partial sum of s of n of the arithmetic sequence that satisfies the given conditions. So I'm given that a is 3, d is 2, and n is 12. So here, looking at my equations, I'm not given the a sub nth term, so the second formula would probably not be the best thing to use. So the first one probably be the easiest because all I need is n, a, and d. So I'm just going to use that one. So s sub n, or it looks like it'd be s sub 12 in this case, will be 12 divided by 2 times 3 plus, and then 12 minus 1 times 2. Okay, so now all we need to do is simplify. So 12 divided by 2 is 6. 12 minus 1 is 11. So 2 times 3 is 6. Plus 11 times 2 is 22. 6 plus 22 is going to be 28. And then 6 times 28 should be 168. And that would be my partial sum for the first 12 terms in my sequence. Okay? Example 4 says they give you a partial sum of an arithmetic sequence is given, and we want to find the sum. So they don't give you a, d, and n particularly. You can tell that a is negative 3, so you've got that. You're actually given a sub n, which is 30. So this one might be easier if we use the other equation, but I still need to know what my n is. And because of the terms, you can either count it, or here's another way of thinking about it. So you can figure out what d is by just looking at your difference. So here to negative 3 to negative 3 halves, and these are all separate terms. So this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. Okay, so don't get thrown off by the plus signs here. So from the difference from negative 3 to 3 halves is adding 3 halves, and then from second to the third is adding 3 halves, from 3 to 4 is adding 3 halves, 4 to 5 is adding 3 halves. So it must be that d, let's make this more apparent, so 3 halves is our common difference. So once I have those, now I can kind of figure out what my n value is. So let's plug those in and solve for n. So if I know a sub n is going to equal negative 3 plus the difference 3 halves times n minus 1, I know the nth term is going to be 30. Now I have an equation that I can solve. So I'm going to add 3 to both sides. So that gives me 33 here I can divide or multiply by the reciprocal of 3/2 to both sides. So let's multiply by the reciprocal here. So it looks like I get looks like it would be 22. Let's go over here. 22 is equal to n minus 1, and then add 1 to that gives me 23. So now that's the 30 represents the 23rd term. So if I go to my, and let's use a different color because there's not much space left. There we go. So S sub 23 would be 23 times the negative 3 plus the 30, all divided by 2. So now negative 3 plus 30 would be 27. So if I plug that into my calculator, my 23rd, or the 23rd partial sum of the sequence should be 310.5. Okay, so that would be the sum for this sequence. Okay, well, have fun.